So I didn't have a big title here, so I'll just go ahead and skip to the About Me. Again, my name is Colin Mollenauer, and I'm from Knoxville. Got my BS and master's here. A lot of my classes were actually in this room, so geographically I haven't moved very far. But so I got as the computer science department before it merged and everything here. So it's just pretty much computer science. So I'm kind of a programmer at heart, and currently work for a company called Business Services and Solutions. It's a very generic name, I know, but we do just kind of lots of different things with lots of different businesses. I'm kind of the integrator whenever we work with new businesses or with our existing businesses. I'm CTO, so I do a lot of software and hardware architecture stuff, getting web servers running at larger scale, writing all kinds of software for improving the business processes and things like that. Some kind of a DevOps. I don't know if you've heard that term or not, but it's just kind of a catchy phrase these days anyway. So I do a lot of security and performance optimization. So I'm kind of in a different field than all you guys are, but we kind of use the same resources, or we at least can use the same resources, big computers. So that's pretty much what my talk is going to be about. And this is kind of the overview. I'm going to first talk about what is the cloud, Amazon Web Services, and then running R on Amazon EC2 and R on StarCluster. So I know several of you have already said that you're familiar with Amazon services. So you're probably going to be, for the most part, familiar with everything I'm going to talk about. I'm just curious, how many people did not know that Amazon did this computing web services thing? Okay, so I'll just go ahead and jump into, I'll jump into Amazon real quick. So Amazon Web Services was launched in 2006, and kind of where the word cloud came from, to be honest. I didn't look up the etymology of the word, but in the technical sense at least. But it's a huge business for them now. It's estimated to be $3.8 billion revenue in 2013, which is, I can't remember their total revenue, but it's becoming a pretty big chunk. And obviously it's a large number regardless of their other business that doesn't really make them a whole lot of money. So that's probably one of their biggest actual profitable endeavors. So they have 10 regions globally. So they have data centers, and each region can have multiple data centers. So they've got lots and lots and lots and lots of computing resources available, which is great for you guys. So back to what is a cloud. So the cloud kind of spawned from hardware virtualization, in my opinion. Hardware virtualization is where you've got the host hardware, and on top of it, instead of your regular operating system, you've got a hypervisor, which is kind of like an operating system that can run multiple guest operating systems underneath it. One or more guest operating systems. It doesn't have to be multiple, of course. And so this hypervisor acts as a abstraction layer so that hard drives can be abstracted to the guest operating system. It would appear that they have full access to the entire hard drive, whereas in reality, they're only using a portion of the hard drive through the hypervisor. The network interface does the same thing, so you can have two guest operating systems that can't see each other's packets. They're completely segmented by this hypervisor. And the resources can be allocated to each guest operating system by the hypervisor. So one guest might get 128 megabytes of RAM, the other one might get 16 gigabytes of RAM, and it can control all this without restarting the machine. In fact, each guest operating system, it can reboot, and it thinks that it's actually getting a power cycle. So the hypervisor pretty much deceives the guest operating system into thinking it's running on real hardware, when in fact it's kind of running in this abstracted virtual environment. So that this whole virtualization thing can be automated like crazy, and it gives you kind of virtual machines as an internet service. So the infrastructure as a service is a big kind of a all-encompassing phrase, I guess, for this cloud idea. So it gives you easy scaling. You can reboot your machine and have twice the amount of RAM without actually physically opening the machine up and putting more RAM in it, assuming the host machine originally had that much RAM, of course. It gives you easy automation via APIs, economies of scale via multi-tenancy. So Amazon has, let's just throw out a number, like 20,000 machines running in a data center, and they could have 100,000 customers in that data center. So they don't need one physical machine per customer anymore. They can have lots of customers, 20 plus on one machine, or 2 or 3. They can completely scale it however they want to, and it doesn't require actual one hard drive per customer, one network interface, one CPU, et cetera. And then the stability can be benefited as well. If your physical machine starts to have issues, just shut it down and then boot it up on another machine. So it's great for all kinds of reasons, and different people use it for different reasons. Most of your school's supercomputers probably don't use virtualization, partially because there's a little bit of overhead. The I/O performance is impacted a little bit. Even CPU and a couple things. It's actually improved quite a bit. All the CPU manufacturers like Intel have special features built into the CPUs and the hardware these days, so that hard performance hit is reduced. So it's to the point where it's almost negligible. And I wouldn't be surprised if in the future more schools do start virtualizing their clusters just to take advantage of some of these tools and other things built around virtualization. So Amazon Web Services is the only cloud I'm going to talk about. There are lots of others. Windows or Microsoft has Azure. IBM's got a cloud. There's lots of other cloud companies out there. Amazon was kind of first to market, and I think they've executed it better than everybody else. They've got, at this point, I don't know how many services that is, 20-something services, and the only two we're going to talk about are EC2 and IAM, but it's possible that some of these other services are things that you could benefit from as well, especially if you're like a department head and you want to give your department access to these things. There's features in here that could help you automate, student, like a VPC is like a virtual network service. So lots of different services available, but we're going to talk about EC2 and IAM. So first thing I'm going to talk about is just the web services themselves. It's a lot more complicated than just having like a username and a password. Well, I shouldn't say complicated. It can be more powerful than that. At the most simple level, it's almost nothing but just having a username and password. So one thing you have to be aware of is account abuse. Like if you are a professor and you've got some research assistants working for you, not that they would do anything wrong, but maybe their username and password gets stolen via email, or you don't want to be like emailing your Amazon password to people. Pretty quickly, somebody could rack you up a humongous bill, launching thousands of machines, doing illegal things with them and stuff like that. So you definitely don't want your account to get abused. And I'm not saying your students will do it, but as a general security protocol, don't give anybody access to anything they don't need access to. So never share your root credentials. I mean, if you're just paying for your own account, then you can use your root account. You don't really need to do all this extra user stuff. But definitely don't, just keep that really protected. They do support a multi-factor authentication, so like if you have an Android phone, you can use that Google Authenticator app, and all the smartphones have different apps for these things. But that basically would let you, like if a new unrecognized or unauthenticated computer tried to log into your account, it would require that you put in a number from either an app or a key fob. So that's like an extra level of security. And finally, they have this IAM service. And this is like their only service that's completely free because it kind of just augments all the other services. So the 4 types of credentials we're going to be talking about. The first is just your email and password. That's like your root account. So if if you've already been shopping on Amazon, you pretty much already have your email and password. As soon as you go to the AWS website, you've probably already done this. You can put in a credit card again, and they'll confirm via phone that you're, not someone trying to create a bunch of bad accounts or whatever, and you've got access to Amazon Web Services. The second is the IAM username and password. So you can create a group and you can create sub-users, and you can give those user names out to people, and that way, if you've got 4 research assistants, you can give each of them their own username, and that way, if one account gets stolen, at least kind of where it got stolen from, or whose account got compromised, and it's definitely a lot better than having one username for the whole department. Although for small groups, might not make a huge difference. And then the AWS access keys are kind of like a username and password, but you don't get to choose them. They're chosen for you. They're really long. You just kind of copy and paste them somewhere. But you definitely want to keep those secure, because that's what is basically, for the purposes of the Amazon Web Services API, that is the username and password, essentially. So you want to keep those secure, and we'll go into that a little bit more in a minute as far as sub-users and all that. And then the last one is key pairs. So when they say key pair, they're talking about an SSH key pair, a public key and a private key. So if I generate a key pair, it results in 2 files, a public key and a private key. I will keep the private key private. I don't want to share it with anybody. You don't want to email it to people, ideally. And then I can put that public key on a server, and using the private key, I can access that server. So the public key is similar to a username and password, except for wherever I put that public key, they don't know my password. So if I set the password on the server, it's potentially a key logger or something like that could log that key as I'm typing it in, or if basically, like, I can give someone else a public key, anybody a public key, don't have to worry about the security of my private key, and I can access that resource that they're holding. So we'll talk a little bit more about that, but not a whole lot. So first, the IAM, the Identity and Access Management. This is basically Amazon's big system for all of their other web services. You can control exactly who can do what. So down to the finest level of, they can list my machine, my EC2 instances, or they can start and stop my EC2 instances. You can either just give them full access to everything, or you can restrict access to certain things. So it's really powerful. You can create groups, lots of users. So each user gets their own access keys. And the AWS Management Console is kind of an optional thing. You can actually start up machines without using AWS Management Console at all. And it also allows for things like consolidated billing. So in the department head situation, maybe the department has one account, and there's multiple professors that each have their sub-accounts, and they all get billed to the same department account. So there's kind of you can have sub users using that. So it's really flexible, and it's not specifically geared towards universities, but it's just meant to be as general as possible so that it can accommodate whatever situation. So definitely, it's possible to set things up securely so that certain people in the department have certain access, only what you want them to have, and it all gets billed to one account nicely, and you can everybody just gets the work done and don't have to worry about too much password management and things like that. And also, the API calls can be logged via CloudTrail in case you're concerned about abuse and things like that. So the access keys, there's a key ID and a secret access key. Like I said, it's kind of like username and password. One thing is that I'd noticed just today, actually, because I've always just logged into my Amazon account, which is kind of ironic, like having the keys accessible via your username and password basically makes them only as secure as your username and password. So they're trying to lock these down because they're so important. And you can rack up thousands of dollars in hours with someone's Amazon account if you wanted to. So they're actually locking them down where you won't be able to retrieve them online anymore. So you definitely want to store those somewhere on your computer using ideally some kind of encrypted system like KeePass, or there's scads of different password management programs, but ideally not like in a text file. I mean, if someone stole your laptop and they found your AWS access keys, you could be racking up thousands of dollars per hour. So security is definitely important. And the IAM users keys and the root users keys are pretty much interchangeable as far as tools go, as far as like accessing the actual resources. So there's no real difference between them at that level. So the key pairs. Yeah.
Okay. So if you can't do online retrieval after April 21st, and you forget what your key is there an alternate route where you just?
They made it sound really bad if you lost your keys. I don't know exactly what happens, but like maybe with a phone call you could get it, but like there won't be any kind of like automatic online retrieval, it sounded like. So yeah, I don't know how bad it is, but it's like big red text, save your password somewhere. Yeah. Sorry? With the SSH key or the access? Yeah, you can terminate. Assuming that the access keys had that permission, which like the root account would, you can. Yeah. That's another good point. They could get in there and delete all your stuff. Like they could make your day really bad. So don't lose your access keys. So the key pairs. This is just a standard SSH key. Probably some of you are already familiar with this. Using the command line tool SSH keygen, you can generate a key pair, or you can let Amazon do it for you. And then when they do that, it'll download the private key for you, and they'll have the public key. Otherwise, you can generate one using SSH keygen and then import it using either the web console or the management console or a command line tool. So if you're a Windows user and you want to use command line access to your EC2 node or your cluster, I like using PuTTY. Using PuTTY-gen, you can import keys. So like if you generate the key on Amazon, it'll download a PEM file. And if you want to use that with PuTTY, you've got to convert it to a PPK file. And PuTTY-gen does that for you. It's pretty simple. Just import and then save. And then a P agent, that's actually how they spell it. I don't know why, is a tool that basically you can add your key to that. And then whenever you try to log into a system, it doesn't require your password. So keys are a little bit more pain to set up than regular passwords, but if you use it a lot especially, it's a lot more convenient in the end because you don't type your password over and over and over again. Also, one note, your private key, either it can be password protected or not. So if you don't use a system like KeePass or something like that to hold all these things, it's a good idea actually to make your private key password protected. And when I say password too, it's better like a passphrase. Just think of some sentence that you won't forget. Make that your passphrase. When you launch pagent, like when your computer boots up, you put it in one time, and then as long as your computer's up, it's basically unlocked. So if you kill that pagent program, then you'll have to just type in your password again the next time. So that's a really great way to access the servers. It's a lot better than some consoles. Like it resizes as well. It has good font rendering, stuff like that. So for Mac or Linux, they just use the basic SSH program in your console or terminal, whatever your system calls it. And so with SSH, you just specify the private key using the -I option. And that's kind of a pain. And if you set it up like this up here, so the SSH config file, you can add a host, a rule like that, and basically it'll apply that identity file for all hosts that match that format, which is the standard DNS format for Amazon. So that's kind of just a more convenient way to use SSH. And also SCP is the equivalent of, like, if you want to copy files to your server. So instead of typing SCP -I private key path, you can just set up your config file like that. So EC2 is Elastic Compute Cloud, and they've started out as like 2 or 3 different instance types. I think maybe like 3 different instance types: small, medium, large, or something like that. And now they've got probably 30 something to choose from. So I just kind of gave some examples here. Like the C3, the C ones are like compute optimized. So some have more CPU power and less disk space, and some have more RAM and less CPU power and things like that. But the compute ones are basically CPU heavy and like disk light. And pretty much most of their options now have SSDs as well, which is great. If you're, you run into swap space on your node or something like that, it's definitely a benefit to have an SSD. So these are, well, also there's a free tier that you can use for 1 year. Once you start it, you can use the free tier for 1 year. And it's really, really cheap, though. Like the micro instances, I can't remember, a few cents per hour, something like that. So the different billing methods are basically on demand, which is hourly, and reserved and spot instances. So you can reserve them for a month. You can reserve them for like a whole year. The spot instances are kind of like you can bid on them to get like whatever they have excess of cheaper than if you just reserved it. So there's lots of different ways to pay for it. Then you'll pay for these little kind of like incidental costs for the most part. If you're not doing like massive amounts of uploading and downloading, it won't really add up to anything, but it's just something to be aware of. So there's basically the hourly charge for the EC2 instances plus these little incidentals. So when I was looking, I haven't actually seen the R3 8X large available for some reason. I know they only offer those in certain regions or data centers, but I didn't see it as an option when I set mine up, so I'm not exactly sure why that is. I know, well, the R3 is like to be determined. I think they're still launching it. Back in January, they launched one called CR1, I think, that also had 244 gigabytes of RAM. So if you're looking for like massive amounts of RAM in one node, then EC2 is a great way to get that. You might not even have to worry about, you still have to worry about parallelism, but you might not have to worry about actual like distributed computing. So just getting the biggest instance you can probably makes more sense unless your code's already capable of being distributed against multiple instances. So we'll first talk about single instance use, and then I'll go into cluster use in a minute. Is there any questions about use it, like the billing or anything like that real quick?
Are the cores multi-thread, or are they?
Yes, I put cores in quotes there. It'll appear to your instance, this is that virtualization thing, that you have that many cores. Those cores aren't like dedicated to you, and So you can't really compare this to like just a bare metal is what kind of the term is for non-virtualized computer. So like 4 cores here, like 4 cores, 32 cores, it's going to mean you can like run 32 threads or whatever at the same time, but it's like you don't have necessarily dedicated access to those. So like the C3X large, it's got 8 gigs of RAM. It's probably running, honestly, on at least a 64 gig machine, which means there could be 8 other people on that same machine. So I'm not exactly sure how their hypervisor works. Some of them have some hypervisors give you like burst stuff, and some of them give you like actual. I'm pretty sure Amazon's hypervisor is like actual. A certain amount of the CPU power is reserved for you. So if all 7 other people are using their CPU to 100%, you should still be able to use yours unaffected. But it's not like directly comparable to bare bones or to bare metal computing. So they actually have a number they call, I can't remember the name of it. It's like an equivalent of it's like a rating system. Like I think they call it compute power or something. I can't remember, but they basically rate like this node has 10 units of computing power, and this one has like 100, and that would mean that it's like 10 times more powerful. So rather than talk about gigahertz and stuff like that, they use this compute.
Clock speed.
Yeah, they're talking about clock speed. They use like this compute power, just arbitrary number that they model they came up with. Yeah.
So I didn't know about the management, the account management that you talked about a little earlier. One of the reasons that my lab hasn't embraced this was that there's always the fear that someone will leave an instance open, not in something malicious, but just not that you shouldn't trust your research assistants in sort of the way you said, more that you just don't close an instance correctly, and the thing just kind of spirals.
Yeah.
And that's happened a couple times to some of my collaborators. And so I'm wondering within that management whether on a different user basis you can supply kill times such that if a process is running too long, there should be this automatic kill.
Yeah.
So that, I don't know, you build it in like some people are more trustworthy, less trustworthy, they should kill things. But I think that's actually a good step forward. Is there a way to set that up?
Yes, but not like, it's not an Amazon provided out of the box. Like actually originally, Amazon didn't even have a management console. It was just 100% API. So they've added the management console that kind of lets you do just about everything the API will let you do. But the API is kind of a low-level tool. And something like making sure that your instances don't sit idle for hours on end would be kind of a level above their low-level tools. So
of course, the whole point is that if someone's not, I shouldn't say smart enough, but if someone's not aware enough to make sure their instance is closed, they're also not going to be aware enough to put in a kill time.
Right. Yeah, possibly. But there's one of the great things about AWS is just there's like so many people using it, and there's so many great third-party tools. I don't know about like idle stuff specifically. And they do have like an elastic compute cloud thing, an elastic load balancer and things like that, which is not really for that. It's more like you can have elastic load balancer that, if you have high load, it'll spin up more nodes for you. As it goes down, it'll spin them down. It's probably not really what you want because you want them to be available when you need it and then gone when you don't. So you could definitely write, and there might have already been something written, I just hadn't looked, that monitors nodes, like if they're idle for over an hour, it kills them. It would be pretty easy to write something like that, and I mean, like with some bash scripting or something like that, it would be pretty simple to do, I think. But yeah, they're not out of the box. There's not like a maximum idle time that you can set or anything, at least not in their core tools. So. Okay, so first thing, we're just going to throw up a single node running RStudio. So RStudio, probably are familiar with it, but if you're not, it's basically like a web server that looks just like the RStudio IDE. It's web-based, and you can either, so they use these AMIs. It's a Amazon Machine Image, I believe is what it stands for. And it's basically like a disk image. And they store these images. There's like their supported images, which they have like Ubuntu and I think CentOS, Red Hat, Enterprise Linux, and things like that. That just kind of like a bare bones install. And then there's scads of community images, which are maintained by just all kinds of different people. Lots of web server stuff and things like that. There's one built by this guy that already has RStudio installed on it. It's based on Ubuntu. So it's pretty easy to do it yourself. Basically, you can just spin up a Ubuntu AMI, run apt-get install rbase, and you have at least R. RStudio installation is a little bit more involved, so I just went the easy route and chose a community AMI. Also, Blaze set up a AMI that's, I think, probably similar to the, should be a 1320. There's no such thing as 1320. Anyways, Blaze set up an AMI that's got RStudio on it. So, if you can find an AMI that's got what you want on it, it's easy. Instead of you paying for the, well, you'll still pay for the storage once you spin it up, but basically, you can kind of choose build your own route, or just find a community AMI that's got what you want already installed on it, and maintained by someone else, possibly. So the setup wizard basically has got these steps. You choose the AMI, and these AMIs all have these ID numbers, and those ID numbers are actually specific to which data center or region they're in. So like this is a AMI number for that RStudio image in the US East region. I can't start up a instance in the US West region using that AMI. I have to find either it might not exist in that region, or it exists and has a different AMI number. So when you start up the console, there's actually a just go ahead and do it. So there's some high security for you. That's why they quit giving the AWS keys over the over their website. So, so basically, you just go to instances here, and launch an instance. And so here's the quick start AMIs, like Ubuntu, for example. Then I don't have any AMIs currently. And if you go to the community AMIs, you can search. So this is the one that, actually this one right here is what I'm talking about. So you select the AMI. You get to choose an instance type. So these are all the different options. General purpose, memory optimized. So the ECUs is what I was talking about. It's the CPU capacity. So there's just like a number that they came up with to let you compare how fast is one compared to another, because they might have different types of CPUs, and there's also like the network stuff differs. EBS optimized is just like a faster I/O system. So I'm just going to pick the good old T1 Micro. And for the most part, everything else is, you can just launch it with the defaults. Nothing special here that you need to worry about. The storage by default, that's your, depends on the EMI or the AMI that you choose. Some of them might have multiple disks already configured. Some of them might just have one. Might be large or small. So this is just the default that one comes with. It's good for me. You can tag them with different things for organization if you have hundreds of them, but just one, it doesn't really matter. So the security group is one thing you do need to worry about. Security group is like basically your firewall rules, essentially. So by default, it gives you SSH access, which is the PuTTY on Windows, or this SSH client on Linux or Mac. If you want to use RStudio, then you need to open up the web interface as well. So just click Add Rule, choose HTTP, Windows 8. So this basically opens up TCP port 80 to anywhere. You could restrict that anywhere to be like just your school network or something like that if you were concerned about security more. And finally, you just review and launch, and you launch it. So here's the key pair thing. You can actually proceed without a key pair if you know the password that was set up in the AMI. So some of the AMIs, they say on the well, actually, I don't think that they do usually specify password. That'd be really insecure. Basically, as soon as you launch your AMI, somebody could just be scanning for an AMI that's running with your, and they already know the username and password. So now, in the case like a private, like if someone shares an AMI with you, they can say, yeah, the password is such and such, but it's probably not a secure password. So best thing to do is just go ahead and deal with this key pair thing, get it straightened out, and you'll be happy you did later. So I already created a key pair called Colin, but I can create a new key pair just for kicks here, and call it Colin 2. So when I click Download Key Pair, it's going to download this PEM file. How many Windows users do we have in here? So about half, I guess. So it downloaded that PEM file. If I run PuttyGen, so if you just search for Putty, I think I'll also put a link on the slides, you can download an installer you can either download just the executable or an installer. I just recommend go ahead and get into the installer, and that way you'll have all these tools. So I'm just going to convert import key. Downloads. So I'm going to import my PEM key, and then I'm going to click Save Private Key. So it's asking me if I want to protect it. So this, let me do that again. So if I want to protect it, I should put a passphrase in here. And that, like I said, just like a long sentence or something like that you won't forget. That way, if the key gets stolen, it's still actually secure. So it's like a password for your password, but it's a good idea. But I'm just going to say no. Do as I say, not as I do here. So save to my desktop. Actually, yeah, I'll just save to my desktop. So I've got my PPK file now, which is like a Putty compatible version. If you don't, like if you're using Mac or Linux, you can just use that PEM file as it is. It's essentially the same as the ID_RSA file that SSH keygen generates. So I can close the key generator application here. Actually, let's see. So I've already got pagent running right here. I'm going to click Add Key. And what I did is actually, I just created a startup link. You can put your startup link, like a shortcut, and what Windows calls it. And you can actually put the path to the PPK file in that shortcut, and then it'll load it automatically on startup. So you can skip this manual selection step. So if I select my new key right here, open it. If I had password protected it would be asking me for a password, and I'd have to type that in, and then it would be kind of like unlocked for this session. So I'm going to go ahead and launch instance. All right, so it's launching, and it takes like a minute or something like that to be ready to use. So here's my, this is the management console. Under the instances tab, I've got this instance pending state currently. Actually, US West Zone. So it's launching, and basically, once it's up, I'll be able to access it via SSH or HTTP. And let you just take my word for it. So we can get back to the presentation here. I guess I have to skip through here. Okay. All right, so we did those 7 steps. You end up having, after it's actually running, you have the public DNS and your public IP address, and those actually are not static. So if you shut down or stop the instance and start it back up again, those will change. If you like having a static IP, you can use this elastic IP, which you can manage down here. When you start the instance, you can assign it to one of your elastic IPs. The elastic IPs are free as long as your instance is running. If you shut it down, they charge you like half of a cent or something like that per hour. So it's like, I can't remember. It's like a couple dollars, like $1 to a month. I think that's right. So you don't really, it depends on how you want to access it. If you're just going to access a single EC2 node all the time, Elastic IP is probably worth it. Otherwise, for the cluster stuff we'll go into in a minute, it's not really worth it because the tools handle it for you.
I don't know if it's the appropriate time, but my question would be sort of just from your own experience, if you were going to use this for your business as opposed to a scientific application, how would you figure out what size of resources you need? I mean, what kind of, it's going to be a process. What would you do?
So like, for me, pretty much everything I do is, runs 24/7. It has to be completely available 24/7. So, definitely would want to like optimize, don't just buy the most expensive instance. I think that R3 8x large would be like $2,000 a month. So, 10 of those, adds up pretty good. If you're running it 24/7. So definitely, yeah, I mean, well, like in my case, I would actually want to just way overshoot and look at the load and see if it's way under load. If I'm using 4 gigs of memory and I've got 16 or whatever, I know that I can go down. In the case of if you have a big job that you want to run, you just want to get it done. And you think it might be a 5-hour job, and I would just probably pick a big one, throw it up there. Probably a good idea for RAM mainly to calculate how much RAM you need. Try to figure that out. If you've got a gig of data and you're somehow duplicating that data 20 times, you might need 20 gigs. Throw in an extra 20%, something like that, and kind of go from there. And hopefully, if it only runs a couple hours, it's going to be like $5 or $10 or something like that, or even $50. But
Test cases, like for instance, for the test script that you can put up and see, well, here's where it bogs down if I hit this big.
As far as performance monitoring, you could just like log in with SSH and then run like top or something like that to. Top like shows all the processes that are running, how much RAM each one is using, what the load average is. So like the load average number in Linux is it's kind of like a CPU usage, but like if you have 32 cores, a load average. It's like how many processes are waiting to be run. So if it's below 1, then that's pretty light usage. If you have 32 cores and it's like 8, you're getting good use out of your machine. If it's 32, you're basically right at the max. If it goes over that, then you're basically everything's backing up waiting for that stuff to complete. So that's how you kind of gauge CPU usage. Yeah.
Are the instances identical in their infrastructure besides the underlying thing that you're selecting? So what I'm really asking is, like, could I run some code on a micro instance to test if it works, and then would it be identical to just doing the same thing on a new type of instance?
Yeah.
So that regardless of, so you were selecting for that guy, that RStudio instance.
Mm-hmm.
I'm sorry if I'm using all the
AMI, yeah.
AMI instance are different. If I'm using the same AMI on two different instances, the underlying infrastructure is identical.
Yes.
Okay, because one of the problems, this is the same problem that we use large computing clusters, is that I'm writing something on my laptop and have it run in parallel. I just do a little 4 cores, right? And I want to distribute it to 500, but the underlying infrastructure of the cluster is a little bit different than my laptop, so it actually doesn't work exactly the same. So it might be the right strategy to open up a micro instance that I saw up there,
yeah.
and try to see if it runs through.
Yeah, make sure you got your libraries all installed,
right,
and all that kind of stuff.
And then if it runs through, then jump sort of progressively higher.
Yeah, absolutely.
Okay. That's as long as the AMIs match up, because obviously if they don't, then.
Yeah, I mean, if you're going to be running like 10 huge machines or 20 or whatever,
Right.
then yeah, you definitely don't want to be like debugging, while the clock's ticking. So that's definitely a great strategy. Is just get it working on the micro instances or like the small instances. There can be a few differences. Some of them have like the EBS provisional back storage. So EBS is Elastic Block Store. It's like basically like their shared their network file system in a way, and they basically just have like the regular EBS and the EBS provisional, I think it's called, and it's like a higher performance, but it works the same. So you could still test on a micro instance and then launch it on your super instance, and the AMI image. You can actually do that with the same image. I mean, you could. So when you, I was going to go into this in just a minute. So I'll go ahead and go into that, I guess. So what just happened? Basically, EC2 created a new instance with a unique instance ID. So the instance ID begins with an I hyphen and then a bunch of random characters and numbers. It cloned the AMI that you chose. So it created a clone of that, and it's now stored on an EBS volume that you are paying for. So that EBS volume is persistent until you terminate it. So when you start an instance, it's running, you're paying for everything. You can either stop it or terminate it. So if you stop it, it just basically shuts the machine down. You still have your EBS volume still exists in whatever state it was left in. But if you terminate it, it'll delete your EBS volume. So if you don't want to pay for all that storage, it's not expensive, but if for some reason you don't want it anymore, you can terminate it and delete that EBS volume and not have to pay for it. So like in the case of his example of trying to get debugging versus running your actual production problem, you could launch it with a T1 micro instance, get it all working, stop the instance, don't terminate it, and that way all your libraries that you installed or whatever customizations you made are all still present, and then create a new instance, point it at your, you could actually set it to use the same EBS volume, or ideally I would just say try to like script stuff. So like if you have this list of libraries that need to be installed, try to script that into something so that you can just basically, like if you accidentally terminate it or something like that, you can still reproduce that going forward. Also, this is a complete aside, I would definitely recommend using like Git or something like that for version control. So everybody here, or how many people here have heard of Git or version control? Okay, so it's great that most of you guys are using it already, or at least have heard of it. Yeah, I guess it's kind of hard to not hear about it with all the open source projects hosted on GitHub. But if all your work is in Git, you could basically launch the AMI Git clone, and then you're ready to go, right? So that's a great way to do it too, and that way you don't have to worry about terminating your instance so much. Okay, so we got the cloned AMI. It's now on our EBS volume. EC2 assigned it a private and a public IP address. And like I said, the elastic IP address is the one that's static if you want it. And the security group that we set up determines your firewall restrictions for those IP addresses. There's also the private IP addresses that you get without configuring them. And those are used for the if you're doing a cluster. But for the single instance node, you don't even need to worry about that. So it booted the virtual machine, and it installed your public key so that you could log in with your private key. So real quick mention of the EC2 command line tools. These are tools that are officially supported by Amazon. On their webpage, they have like instructions for installing them. It's basically a Java, or they just require Java is the only requirement. Can do basically, there's like one command line tool for like every one of their API calls. So you can see they're all really low level, like describe this, start this, stop that. But they're good for things like if you want to just get your instance IP address from a command line, you can use something like that, or your DNS name, or your instance name. You know, like the describe instances will, dump out for every instance that's running a tab separated text, and then I grep it for the instance. It's like the first word of the line that contains this, and it's like the second field using cut. That extracts like the second tab delimited field or whatever. So if you could do this on Windows too. So Windows you wouldn't be able to use grep or cut, but in fact for Windows what I recommend doing is just installing like Git for Windows. Includes a really good bash console. Do you have a question?
Oh, I was just going to say I didn't know about the Git console. If you install Cygwin, then you have.
Yeah, I actually prefer Git for Windows over the Cygwin. It integrates a little bit more nicely, like the paths to your files are like /c/ whatever, and it includes all the. It's just like a really easy install. But yeah, Cygwin or Git for Windows would be a great way to get bash on Windows without like installing a whole virtual machine on your local client if you didn't already have that. So here's just an example using the command line tools. So I just use a set of bash variable called instance. I did EC2 start to start that instance up. So you could put all this in a script if you wanted to. Basically, oh, I'm ready to run my problem, or I'm ready to start working on my code. I'll just run my start script. It starts up your instance. So here I just created like a file called test.r that just does nothing but print, and I use SCP. And now here I use the -i, but if you did that SSH config, then you can leave that part out. So I copied test.r to my EC2 instance test.r. So that puts it in the home directory. So the user, by the way, the default user other than root is just called Ubuntu on that AMI that I'm using. So basically, I set that as the variable, so that's why I'm able to use it down here. So I just copy basically local to my remote machine. So using SSH, I'm running this command r quiet, so like don't print all the console stuff out, and then read in test.r, so it prints ka-chow. So that's actually the output of this through SSH comes down on my console. The other way to do it would just be to simply SSH or SSH into the machine and interact directly on the machine. So here's another example. You can just do R interactive even. And then when I'm done, just EC2 stop. So at that point, I'd only be paying for the EBS storage like 5 cents a month per gigabyte, so 20 cents a month, or 40, sorry. And it takes like a minute roughly to be able to actually start using the machine once you're set up here. So that's kind of like the EC2 like single instance usage in a nutshell. Does anybody have any questions about that? And keeping in mind I'm not an R expert.
Related to the is there a way to tell the instance to notify you when your job is finished?
Yeah. So that's one great thing about using this method here rather than using rather than SSHing into the machine, because if you SSH into the machine, when it finishes, like if you SSH an interactive session into the machine, once it finishes, like it's gonna be prompting you to do something, right? So if you use this, you're sending it a single command, and your local shell will wait until that command finishes, and then it'll go to the next thing. So you could actually script all in one bash file, start instance, run my test using this, and then stop instance at the end. That would let you, run your job and it would stop immediately. And then, like, if that R program, prints out to the console, then you could pipe this out to a file, or redirect that to a file, for example, and have all the output of your R program. And you could come back, the next morning or whatever, and you'd have your output, and your instance would be stopped, like the second it was finished. So, yeah, if you have like one, if you have a R script that you can run, this is a great way to do it because it starts it up, runs it, and then kills it immediately afterwards. If you do the SSH interactive, then it's a little bit harder to script that because, and I guess you could probably run like SSH, like just this part right here, and then as the next command, like semicolon AC2 stop, and I think you would still have, like, basically as soon as you exited your SSH session, it would stop it. So that'd be another way to do it.
If you do script it, do you need to leave your terminal open?
There's ways around that too.
The SSH command? I guess no.
Dash uppercase I, or? OK. Yeah, I mean, SSH without any arguments is like the interactive
Right, yeah, I was
session.
thinking about no huffing something. But
Yeah.
But that's different if you're,
Yeah, I mean, you could run. I mean, something's got to stop the instance. I guess you could have the instance stop itself if you like put your AWS keys on the instance and then use a command line tool. You could have the instance stop itself. I don't see any reason it couldn't. If you wanted to be able to shut your laptop down and still have it running, that would be one way to do is just have your instance kill itself.
You can
basically.
SSH to your mainframe at work and then run it off there, which is always going to be up. And then you shut your laptop off. It's not a problem as long as you use no huffer screens.
Yeah, just be careful nobody walks along and sees your AWS instance running. But yeah, I mean, yeah, there's like if you have like you said a school computer or something like that that's running 24/7. Tmux is my favorite. It's like Screen. So Screen is like you can run bash inside a session and detach from it, and it'll keep running. You log back in, reattach to that session, and it has everything exactly where you left it off. Well, it'll actually be running still. So I mean, if it's doing stuff, you'll have your whole console there. So Tmux, TMUX is a like Screen, but better. And basically, that would be a great way to do it. If you had like a school computer, any school computer, it's log into it, start a Tmux session, do your EC2 job, and then detach. Instead of exiting, you could just hit whatever the command key is, like Control D by default. I can't remember. I use Control A. So you hit like Control A, D, and that would detach it. Yeah.
One of the things is Amazon does have cloud watch.
Okay.
So this is the alarm is very safe and hit in other instances. And you can monitor things like CPU usage and use that alarm to stop the instance so that after the process is done, it can do. And it also can be used for monitoring billing, send email alerts and billing.
Thanks. Yeah.
Is there a command line tool to initiate an EC2 instance?
To like create one, or?
Yeah, just to create.
Yeah, you can create them through the command line. I think it's just like EC2-create-instance, and then you got to figure out all the.
Yeah, how do you log into Amazon that way?
Okay, so the command line tools. I can't remember if I guess I didn't go into exactly how to set this up. So basically, the command line tools, their help page explains it all, but you have to have Java installed. Your Java home variable has to be exported. And then EC2 home, so you export another variable called EC2 home, and then you export two environment variables called AWS access key and AWS secret key, I think. In Windows, you can set up environment variables in Windows as well, so that you'd be able to run all this in Windows. Although if you're using Git for Windows, you could just have basically just put those exports in your .bash RC file, and then anytime you type an EC2 command line, it'll use those keys. Yeah, so there's basically an EC2 create instance, and you can create the instance, and figuring out all the options if you're just going to do it once, it will take longer probably than just using the management console. So that's basically the next thing we're going into is, they've got all these great command line tools and APIs and everything like that. If you're doing a cluster, you can do a whole lot better than manually setting up. There's a bunch of different tools out there. One I'm going to talk about is called StarCluster. So it's developed and maintained by MIT guys. It's open source. It's all Python scripts, basically. There's the website. So the installation was a little bit rocky. I did it on Ubuntu and Windows. I don't have a Mac, sorry, so I didn't install it on a Mac. But hopefully, I'm guessing Python's already installed on Macs anyway. And then sudo easy install StarCluster hopefully will work. If not, you might have to do some Googling to figure out. I had some issues with a PyCrypto library that didn't want to install. The dependencies didn't want to be resolved. But yeah, so once you get StarCluster installed, it gives you basically a StarCluster command. So on Ubuntu, that should work. I'm not guaranteeing it will, just because they're different versions, and you might have some other version of Python installed that didn't work or something like that. But for Windows, you can install Python 2.7. Just download the MSI installer and install it. Install Git for Windows, and you don't actually need Git for StarCluster, but I don't care to script anything in batch commands, and I'm not a PowerShell user either. So basically, I just install that so that I have bash. So I started Git bash console. I already created a script at that URL that will install all the dependencies for StarCluster. It fixes all the, so it's a little bit rocky on Windows too. There's 2 or 3 different things that have to be installed, but that should work. And then source.bashrc. So this adds the exports that you need, the environment variable exports, to your bashrc file. And then this just sources it at one time. So after you run these commands, the next time you open up git bash, you should just be good to go. So first thing I did is just I aliased StarCluster to SC, because I don't want to type StarCluster over and over again. And that's actually included in that bashrc file. So first thing you do after the alias is sc help. So StarCluster StarCluster help. The first time you run it, it'll say you don't have a configuration file. What do you want to do? The second option copies the config template. So that copies the config template. Use VI or whatever text editor you want to edit this config template. So you have to tell StarCluster your AWS access key and secret key. You tell it which key pair you want to use. So key pairs are required here, whereas they were kind of optional with the EC2 single instance. So if you in the config, if you specify my key, this config is all really self-explanatory. If you specify my key as the key name, then you sc create my key, give it an output directory. So in the config, you'll specify this. So that creates a key. So this way is a little bit different than before when I hit download and it downloaded the private key. This is actually generating it locally and then giving Amazon the public key. So it's the same thing, just different direction. So then basically in this StarCluster config, you can specify a number of nodes, which types of node Do you want like the instance type, the AMI image to use? I'm sorry. Well, you can specify your own AMI, but by default, StarCluster has their own AMI images. I just recommend using those. It's got, I mean, if you did want to use your own AMI, I would basically just start with their AMI, modify it as you want it, save it, and then use that in the future. But yeah, for the most part, you can just use their AMI, like whatever's in the default file. So StarCluster start, and then that's the name of the cluster that you specify in the config, so that's the default one. So basically, like using my key in small cluster, those are the default values. So really, all you have to modify is the AWS access key and secret key to do this right here. The hard part really is installing Python and StarCluster, getting those to work. So here's like a simple bash script that gets a list of nodes into a bash variable that might be useful. So like these are shorthand StarCluster. LC is I think list clusters. So if you just run StarCluster, it'll show the help commands, all the commands that are available. And there's like the long command and the short command. So LC is the short command for list clusters. So I pipe that to grep, AmazonAWS.com. And then this grabs the first token out of each of those lines. So basically what I end up is nodes is assigned. It gets master and node 001. So like with my default cluster, I get a 2-node cluster. One will be called master, one will be node 001. If I did a 20-node cluster, it would just be master and then 001, 002, et cetera. So then this simply installs RBase on each node. So for node and nodes, do StarCluster SSH node, that's like the shorthand for SSH node, the name of my cluster, and this is the variable here. So it's just doing this one node at a time, basically. And this is serially, I guess if you put an ampersand at the end there, it would just run them all in the background. It should get a mess of a console, but it'd be a lot faster if you had like 20 nodes or something like that. So that just installs RBase. So RBase is not installed in the default StarCluster AMI. They have a bunch of other stuff. It's kind of Python-centric, so R is not pre-installed, but you could do RBase and then rcran, I guess is how you say it, to get all the different R extensions and libraries installed. Yeah, so basically, after that, you should have a StarCluster or an Amazon-powered cluster that is ready to use. Yeah, so StarCluster basically just used all the API tools to, well, use SSH keygen to generate a key pair, imported it into Amazon with whatever name you had given it, created all the new instances, created a security group for the cluster. So it sets up the security so that you can SSH into each node, and that so on the private network, that all ports are open. So if you have some system that uses all these different ports, you don't really have to worry about setting up your firewall. It's just everything is open on the private network. Only SSH is open on the public network. Starts all the instances up, creates users, it sets up Etsy hosts so that each node, you can just refer to them. You can do like, if you're on the master and you want to do something for some reason on node 001, you could just SSH in between them. Uses NFS, so it mounts on the master node is where your home directory will be located. And it uses NFS to share that to all the other nodes. So if you copy a file, like your .r files, to your home directory somewhere, all the other nodes should have all those files. So the instance stores are different than the EBS stores. So when you start up, like in the previous example, that AMI that we started up, you just get like an 8 GB disk, basically. If you look on the pricing sheet, it'll mention like how much disk you get. Well, that's the instance store. So EBS is like the shared network storage, and the instance storage is like basically the physical hard drive, of course abstracted through virtualization, but it's the physical hard drive that's on that physical machine. So the instance when you stop the node, that'll get wiped. It's like a temporary, sort of like a temporary directory or something like that, that it does not persist between stop and start, but it's faster and it's bigger than your AMI. So if you have some small amount of data that once you do some computation on becomes a huge, big amount of data, if you want to save that somewhere, you would want to think copy that to S3. So S3 is Amazon's simple storage service. That was actually, I think, their first service. Basically, it's just, kind of like an FTP server in a way. You get and put files into S3, and it's dirt cheap. I think they're down to 9 cents a gigabyte per month, and you can get it cheaper if you do like the low, it's super redundant. If you get the reduced redundancy, it's a little bit cheaper. But anyways, if you have like massive amounts of data that you don't want to keep uploading over and over and over again, S3 is kind of the go-to storage mechanism when you're using Amazon services in general. And then, we just use the bash loop to install R. So that's pretty much concludes the presentation. I'll just take any questions.